Welcome back to the mini lathe build. Next piece I'm going to do is this piece right here, number 15. And I'm going to start with a partial cleanup of this particular part. I'm going to take the gate off. I'm going to clean up the outside, file all the ugly off of it. And then for now, I'm only going to do the 3 holes that are in it without any other feature. The mounting hole and the brackets for the drive shaft are all fit at assembly. And that drives the locking mechanism that goes in here. Mechanism, it's only a screw hole, but it does say see note 4. Note 4 is fit at assembly. There's the sub-assembly that I'm going to work on. These are 256 holes. These are gears and sleeves and screws. Oh my! Very much like the ones I did in the last episode. And we'll mount the rest of the gears and see if we can figure out where this feature goes, which is also fit at assembly. And try to maintain our sanity in the meantime. Let's get a file, let's get creative, make this look like something. A quickie look at it before we start. And I'll be back in a couple of minutes after the file work and see what it looks like. Okay, let's cut the gate off. Setup used to mill off the gate was nothing special. Stacked up 4 parallels just about as high as the vice jaw, locating on the back. I can mill the gate. If I choose to, and I may do so right now, I can squeeze the end mill down in this gap right there and establish the height of that boss. 3/8 dimension is next. Simple setup I changed from before. Locating on the flat surface on the bottom of the casting, or the only flat surface. I'm going to side mill it and easy access with a micrometer. Milling of this component is complete, and for anybody that has called me out in the past for, hey, you replaced that part because it was shiny in one and then it was cast in the next scene, that is. You can see the shiny surfaces on here from the files and from the cutters. I am about to blast this part. I will be right back, and you can see that it will once again look like a cast part. Let's do it. Following a gentle blast, the color is now uniform. All the file marks, all the cutter marks are gone. The blends are quite well hidden. Now I'm going to strap it to the top of my little fixture plate and put in these 3 features right here. Make sure that when you do this, or when I do this, I will do this sitting up on a piece of sacrificial material so I can drill and tap right through the part. Part is currently set up in the mill. I did my standard gauge pin in the chuck. Alignment trick to pick up on these 2 bosses here. Use this pin the same size as the boss. Once I've got these in line, double check this one right here. It looked pretty good. This will be my 0. There will be a gear cluster here. The hole that will be under the clamp here will not be put in just yet because I'm not quite sure where that's going to go. So we're just going to wing it. Drill and tap 2 holes, ream through. Shouldn't be a big deal. A quick check of the print reveals that it is a 125 bushing. It's about a 3mm bushing that goes up against those faces. So I'm going to go 140 on that. Just a couple of thousandths oversized. This has already been machined, so I know that's nice and flat. Ideally, actually I don't know ideally because I'm not familiar with this assembly. So I'm just going to make these nice and clean. I'm not going to clean them up. It's actually going to be a little crater in the center. But when it's assembled, you won't see it. Okay, it's very important they're the same level, so make sure that whatever you do to one, you make sure you do to the other, and they should clean up just for strength. 172 tapped holes going through the center of both of them. Whenever I do an operation like this and I need to know a quick visual reference on exactly how deep that hole is, I will keep my eye on the extension of the spring-loaded tap right there, the spring-loaded tap guide. As this progresses out of the holder, I get a visual reference on how deep the hole is. And it doesn't have to be very deep on this one. I guess that's about 2.5, maybe 3mm tops. Now, I am a little surprised at the design of this. This particular center-to-center distance on these two holes is going to set the mesh distance for a gear cluster that goes on each one of these. Normally, by design and as a good rule of thumb, never use a thread for a precision locator. Production of the bushings is pretty straightforward. You've seen me do it a few times. I'm going to fast forward through this, but I'm going to show you anyway. Alright, finished product. It is pretty small. Let's test fit it before we make the second one. It is always a very good idea, if you're going to be drilling holes and parting pieces off, to keep an eye on the tip of the drill as the number of parts that you produce increases. The likelihood of the drill starting to wobble, walk, and go off center is pretty good. So keep an eye on it, and if you can, recenter drill it every once in a while to reestablish the concentricity of the hole to the material. Watch the drill, see if it jumps around. It may or may not, but just keep an eye on the drill. We're in good shape. Deeper holes, more likely to walk. This is a tip that you really need to understand and embrace to make your life easier. Let's say this is your facing tool, which in this case, it is my facing tool. I'm going to take a pass across the front of this material and I'm going to set my digital readout to 0. You can do it with your travel dial or your travel indicator or whatever you got, but let's do that first. All right, we have a 0 reading on our carriage movement control device. Let's say I want a 20,000 shim off of there. Between my facing tool and this particular parting tool, there is a 180 thou difference in position. So if I move this right now, if I move my digital right now to 180, the edge of that tool is exactly on the face of that part. 180 is my standard for this tool. So regardless of what length part I need, I just add 180 to the measurement that I'm looking for. So if I'm looking for a 20,000 shim, my carriage now moves to position 200.2. And when I start my cut, you can see the 20,000 shim. Now, a good way to double check your standard number, it's going to be different however you set your tools up, of course. A good way to check it is to come up with a standard that you like, make a pass, measure the part, and adjust accordingly. Save that one in the money. Save that one in the piggy bank. It will make you a lot less stress in the world. I know there's an unwanted notch on the OD of this material right there. I'm going to turn that down until that goes away and then cut it off. Save that trick, guys. It's a real good one. And yes, for those of you that ask whether or not I put receiver features on my set screws against my rounds, I absolutely do. If I don't show it, trust me, they're there. This is really hard to do without blocking the camera, so forgive me for this for a second. There's a definite bind. We got to find it. Oh boy. After a couple of minutes of bench time, driving some screws and getting everything to hopefully line up, the upper and lower gears seem to function quite nicely, real smooth. One thing I did add that was not on the print was right under here. I put a spacer shim in there to add the distance between these gears. You can see the gap right here, right inside my fingers, right there. Gives me just a little bit more freedom of movement on these gears. But unfortunately, and this is an absolute straight up, honest to God, don't know why, this bottom gear will not assemble as it should. It just won't happen. I got to say that the reason it's not going together, it's just not happening. It is tight, it is bound up. I've got to say that the dimensions on the print were nailed. Absolutely 4 decimal place nailed. And the 518 number on the PM Research print is not happening. So I'm going to have to set this back up in the machine. Figure out why. First step in the repair, I'm just going to put a pin back in that 125 hole, and I checked it. It is spot on 518 like it should be for some unknown reason. I don't know if it's the pitch diameter on the gears or what the story is, but they are not meshing. Any two of the three, but all three, no bueno. The N2 threaded holes are lining up very nicely, but as soon as you put this one on, it just binds up and nothing works. So I'm going to take and I'm going to move this hole this way 5/1000ths of an inch. And there's only one way to do that, and that is to punch that hole out bigger, put a bushing in there, and either rebore the bushing or bore the bushing pilot hole 5/1000ths off this way. So just for sake of having a concentric bushing and nothing fancy, because if you have an eccentric bushing, if you put a bigger hole right here and drill off center in that bushing, if that bushing rotates, it changes the center to center relationship. So changing the original pilot hole is the better choice. I'm going to take an end mill, a 187 end mill, just the next size up from what we're looking at here, fractional of course, imperial fractional, of course. And I'm just going to go right down through the center of it. I'll take the gauge pins, figure out what size the hole really is, and I'll make a bushing to fit. Just press it in and keep my fingers crossed that I didn't just completely bone this part. So let's do it. Let's do it right. Cutter is just going to be slightly bigger. I do not want to make this wall too thin, so I'm going to go just a little bit bigger. It's going to be a very thin wall bushing. Table is going to shift in that direction, 5/1000 of an inch. That's going to make the hole position shift this way. I'm thinking 5 is going to do it. I'm hoping 5 is going to do it. The hole is officially off center. Here is the bushing that I just made. Extremely small shoulder on it to keep the gear from rubbing on the casting. Let's push these together, assemble it, and hope for the best. We will find out together. Good, bad, or indifferent. Hopefully good. Now let's see if the hole closed up. All right. Over the bench. I still say that looks like an AK-47. Whatever. Here we go. First piece in the puzzle, right there. Second piece will be the smaller gear on the top. And I am not going to tighten any of this down, with the exception of that last set screw. If these guys got to float a little bit, I'm going to let them do it. And here comes the drum roll. This is an extremely small spacer shim. This is 12 thousandths wide with a 5 thousandths step on the one side, believe it or not. And that is to hold the gear on. and still get down in the counter bore in the casting. Moment of truth, people. Here it comes. This goes on, I'm going to be a very happy guy. Let's just say if it goes on and spins, I'm going to be a happy guy. Okay, like I had said before about locating diameters on screw threads, not a good idea, and that's exactly what's taking place here. So you're at the mercy of how true the tap cut into the extrusion, into the casting, as well as how accurate the casting counterbores and such are made. I'm going to take a little bit of pressure on this top one, and I'm going to drive it up to give myself more room, center to center, here to here. So I'm going to pull on it up as I'm tightening it down. Try saying that 3 times fast. Okay. And the gear in the center should just find its happy place. I'm going to push that one down just for yucks. Guys, I'm going to be honest with you, I'm still feeling a bind. After a little bit of off-camera shenanigans here, just strictly messing around with the screws and gapping everything. Didn't remachine anything, didn't file anything down, didn't sand anything. I've got the gears spinning just perfectly fine. They are very smooth. This is an interesting cluster. And you can see how the different heights have been set. The bushing that I put in under the gear on the left that is currently moving keeps these two surfaces from making contact with each other. They will be pulled down and collared into position. And the small shim that's underneath the center gear keeps this area over here gapped sufficiently as not to pick up on the teeth. Everything is nice and concentric. And you can see the set screw on the end on the left side. Got to be recessed into that head. Or it will cause a problem. Anyway, I had hoped to put a couple more details on this particular video, but we're going to see exactly how long this runs in edit, and it may just be that's all you get. If it is, thank you very much for watching. Joe Pye at Advanced Innovations in Austin, Texas. I'm out.